In earthquake-prone countries, renovation actions aim at improving both the seismic resistance and the energy efficiency of the existing building stock are strongly needed, looking at the resilience of buildings against earthquakes as one of the main values of a sustainable city. In this framework, the SAFE project is developing and demonstrating new technical solutions for the seismic and energy renovation of reinforced concrete frame buildings. The project has received funding from the European Union's Horizon 2020 Research and Innovation Programme. It started in October 2020 and will run for a total of 4 years. 12 partners from 8 European countries contribute to its implementation. The e-CLT system is the seismic technology that drives the e-SAFE retrofit innovation. It consists in the application of cross-laminated timber panels on the outer wall of the existing building by means of innovative energy dissipation devices. The aim of the system is twofold. For moderate ground motions, e-CLT panels allow the increase of the seismic capacity of the existing structure. Instead, for strong ground motions, the dampers dissipate part of the input seismic energy. These two features of the e-CLT system allow the reduction of the storage of demand of the structure and consequently the reduction of its damage. The dissipative device is a friction damper. It consists of 2 steel profiles which connect the e-CLT panel of 2 consecutive floors with the existing interposed RC beam. One profile is connected to the RC beam by anchor bolts. The other profile is provided with slotted holes and is connected to the first one by pretensioned high-strength bolts. During an earthquake, when the force transmitted by the damper attains the value of the design friction force, the upper profile slides on the bottom one thanks to the slotted holes, thus dissipating seismic energy. The energy dissipation by friction ensures the durability of the structural efficiency of the damper even after seismic events, avoiding the need for its removal and replacement. The activation of the damper by a predefined force also enables to control the internal force on the e-CLT panels, which can be designed to avoid their damage and the need of their replacement after the seismic event. The e-CLT panels are conceived to be prefabricated and thermally insulating and to be combined with the structural panels, which are applied to the windowy walls and are provided with high-performing windows in replacement of the existing ones. If the e-CLT technology is not applicable or is not sufficient to achieve proper levels of seismic improvement, the e-EXO solution can be adopted. The system provides to connect to the existing RC structure an external steel exoskeleton equipped with seismic dampers. The result is a new external shell for the existing building that acts as a seismic resistance and energy efficient skin and allows to minimize the occupant's disturbance and to reduce cost and time for implementation. New technical systems are also combined to the e-SAFE envelope solutions to reduce fossil fuels consumption and to maximize energy production from renewable energy sources. The systems include plug-and-play decentralized water tanks for domestic hot water storage, reversible electric heat pumps fed by on-site photovoltaic production, and insulated centralized tanks to decouple energy production and demand.